In numbers 24 through 33, we're asked to use the laws of exponents to perform the operations and then rewrite in radical form and simplify the radical. All right, so in 24, a to the 2/3 times a to the 5/3 is a to the 2/3 plus 5/3, because when we multiply like bases together, we just simply add the exponents, and that will give us a raised to the 7/3. And then once we have this simplified, we can put it in radical form. In radical form, it would be the third root of a raised to the 7th power, and that can be factored into the third root of a raised to the 6th power times the third root of a. The third root of a to the 6th is a squared, and we're going to multiply that by the third root of a. Be careful how you write the exponents and the index. The index should be sitting in that crook of that radical. All right, in 25, x to the negative 2/5 times x to the 7/5. So again, when we multiply, we're just simply going to add the exponents if they are like bases, and that gives us x to the 5/5, which is x to the 1, which is in simplified form just x. In 26, 3 to the 1/4 times 3 to the 3/8 is 3 to the 1/4 plus 3/8. And 1/4 and 3/8 need to have a common denominator before they can be added. 1/4 can be rewritten as 2/8. 2/8 plus 3/8 are 5/8. So what we have here is the 8th root of 3 raised to the 5th power, and that's not going to simplify because the exponent under the radical is smaller than the index of the radical. So all we really need to do here is simplify 3 to the 5th power, and 3 to the 5th power is 243. 3 times 3 times 3 times 3 times 3. All right, in 27, y to the 1/3 divided by y to the 1/6. When we divide like bases, you subtract their exponents. 1/3 minus 1/6 can be rewritten as 2/6 minus 1/6 in order to do the subtraction. We need that common denominator, and that's 1/6. So y to the 1/6 is rewritten in radical form as the 6th root of y. Okay, now we have 4u squared raised to the 3/2 power. And when we raise a product to a power, we can distribute exponentiation over the multiplication. And then we can simplify each. 4 to the 3/2 is the square root of 4 raised to the 3rd power. That's 2 raised to the 3rd power, which is 8. And then u squared raised to the 3/2 power. When we raise a power to a power, we multiply the exponents, so that's just u cubed. So 8u cubed. In 29, we have b to the 1/2 times b to the 3/4 divided by b to the 1/4. On the top, we're multiplying like bases together, so we're just going to add those exponents. And that's going to simplify to, that would be b to the 2/4 plus 3/4, which would be b to the 5/4. And that negative b to the 1/4 on the bottom is really just a negative 1 times b to the 1/4. When we divide like bases, we just subtract their exponents. So we have a b to the 5/4 minus 1/4, and 5/4 minus 1/4 is 4/4, which is 1. So now we just have negative b to the 1st power. In 30, we have a power to a power on the top. So we're going to multiply those exponents. So 3 times 1/2 is 3/2. And then we have a division. So that means we need to subtract those exponents. 3/2 minus 7/2 is negative 4/2. and that's negative 2. And x to the negative 2 is 1 over x squared. In 31, we have a power of a product, so we can distribute that exponentiation over each one of the factors in that product. And then 3 to the third power is 27. And then when we raise a power to a power, we multiply the exponents. 1/4 times 3 is 3/4. And then we have that x to the 1/12 downstairs. When we divide, we subtract those exponents, so 3/4 minus 1/12. And let's continue that over here. 3/4 minus 1/12 is 9/12 minus 1/12, which is 8/12. And 8/12 reduces by a factor of 4 to 2/3. So therefore this is 27 times the cube root of x squared. In 32, we need to use the distributive property to multiply y to the 1/2 by a difference in the parentheses. And when we multiply y to the 1/2 times y to the 1/2, we're going to add those exponents. And then when we multiply y to the 1/2 times y to the 2/3, we'll add those exponents as well. So the first term is y to the first power, and the second term is y to the, let's get a common denominator, 3/6 plus 4/6 is 7/6. And so this is equal to y minus the 6th root of y to the 7th power. And the 6th root of y to the 7th power can be simplified as the 6th root of y to the 6th times the 6th root of y. Let's go over here. That will be equal to y minus y times the 6th root of y in radical form. In 33, we're multiplying two binomials. 2x to the 1/3 times 2x to the 1/3 is 4x to the, and remember we're multiplying, so we're adding the exponents. 1/3 plus 1/3 is 2/3. And then the product of the outers would be minus 6x to the 1/3. The product of the inners would be plus 6x to the 1/3. And the product of the lasts minus 9. You'll notice that the two middle terms are going to go away, and we can rewrite x to the 2/3 in the form of the third root of x squared and minus 9. Okay, in 33 through 40, we're asked to rewrite each radical expression using rational exponents first. So the 6th root of x to the 3rd is x to the 3/6. Denominator is the root, and the numerator is the exponent. That will simplify to x to the 1/2. Now the directions say to rewrite it in radical form. In radical form, that's the square root of x. In 35, we have the 6th root of 4. That can be rewritten as the 6th root of 2 squared. Now using rational exponents, that's 2 to the 2/6, which reduces to 2 to the 1/3, and that is the cube root of 2 when we put it back in radical form. For 36, we have the 4th root of 16x squared. So that would be the 4th root of, and let's just factor here, 16 can be 2 raised to the 4th power, and x is x to the 2nd power. And so when we rewrite using rational exponents, that's 2 to the 4/4 times x to the 2/4. And of course, 2 to the 4/4 is 2 to the 1, which is just 2. And then an x to the 2/4 we can reduce that exponent to 1/2. And then x to the 1/2 is just the square root of x. In 37, we have the cube root of y times the 5th root of y to the 2nd power. The cube root of y is the same as y to the 1/3. The 5th root of y squared is the same as y to the 2/5. When we multiply like bases together, we simply add those exponents together. And let's get a common denominator here. It will be 15. So we have 5/15 plus 6/15. And that will be y to the 11/15 when we add those fractions. And now we're going to rewrite that back in radical form. So that would be the 15th root of y raised to the 11th power. In number 38, we have the third root of b squared on the top. That's b raised to the 2/3 power using rational exponents. And then the fourth root of b on the bottom, that's b to the 1/4 using rational exponents. When we divide like bases, we subtract exponents so that the exponent is 2/3 minus 1/4. Let's get a common denominator. That would be 12. So 8/12 minus 3/12 is 5/12. So we now have b to the 5/12. In radical form, that's the 12th root of b raised to the 5th power. In 39, the numerator, cube root of a squared, can be rewritten as a raised to the 2/3 power. Downstairs, the 6th root of a can be written as a to the 1/6 power. When we divide like bases, we subtract those exponents, 2/3 minus 1/6. So that would be 4/6 minus 1/6, which is 3/6. So now we have a to the 3/6. Let's reduce that fraction. That's a to the 1/2. And in radical form, that's the square root of a. Last one in this section. This one's a little bit different. Notice we have different radicals. We have a square root and a third root. And we have different radicands, 3 and 2. So I'm just going to rewrite this as 3 raised to the 1/2 times 2 raised to the 1/3. The only way we can combine these is if the root is the same. And so what we need is a common denominator of 6. So 3 to the 3/6 times 2 to the 2/6. And so that becomes a 6th root of 3 raised to the 3rd power times 2 raised to the 2nd power. So that is the 6th root of 27 times 4, which is the 6th root of, that would be 108 in simplified form.